Today we're going to finish lesson 9.3 and we're going to be doing day 3 on solving rational equations. And day 3 is dealing with solving real-world problems that involves rational equations. Again, equations that involve fractions. So let's go ahead and take a look at the real-world problem here. First problem says, Kelsey is kayaking on a river. She travels 5 miles upstream and 5 miles downstream in a total of 6 hours. In still water, Kelsey can travel at an average speed of 3 miles per hour. What is the average speed of the river's current? So this problem calls for a formula, famous old-time formula that involves rate times time equals distance. I am sure that all of you have heard of that formula and have applied that in the past. So let's take a look at how we're applying it to this problem. So we need to set up a chart. Just organizing it is very important, organizing the information that we are given because there's no table or chart or graph that comes with the problem. So a picture is worth 1,000 words again. So here's organizing your information. So going upstream and downstream, and we have rate times time equals distance. So rate is the first thing that is given is that she travels 5 miles up and down the stream. So means the distance going down and up is the same because the distance doesn't change, just regardless of what your speed is. So we are going 5 miles up and 5 miles down the stream. So that's the information that is given. Next thing we're given is that she travels a total of 6 hours. So the time here total is 6 hours of travel. Okay. In still water, Kelsey can travel at an average speed of 3 miles per hour. And what is the average speed of the current? So if we let C be the river's current, the speed, then going up the stream. So something interesting is when you're going upstream and downstream, there's a little difference, huh? Going up is going a little slower because you're actually pushing against the river. So it's like you against the current when you're going up the stream, right? So the speed is going to be less. So it's 3 minus, take away the current's speed. And then likewise, going up, you're going with the flow of the current. So you're moving with the speed. So there's you, and then there's the current. So you're working together when you're going down the stream. And that is the rate for up and down. And there's a difference, right? So now the last thing that I need is the time to fill out the chart. So I cannot introduce a new variable because I can only use one variable. Otherwise, I wouldn't be able to solve the problem, right? So I want to be able to approach this using C. So in terms of C. So because I know that rate times time equals distance, then I'm going to solve for T by dividing by the rate on both sides. So I get T equals distance divided by rate. So in this case, for going upstream, the time is going to be distance, which is 5 over the distance going upstream is 3 minus C. And then likewise, going down, it's going to be T, which actually is the distance 5 over 3 plus C. So now we got the chart, and the information that is going to help us to solve the problem is this right here, because we have enough information in that column. So I have a new formula right here. The time, so I have a new formula. Time up the stream plus the time going down the stream is equal to the total time. So time going upstream, we are letting it be 5 over 3 minus C, plus the time going down the stream is 5 over 3 plus C, is equal to the total time, which is given by 6 hours. So there is our rational equation, and we are going to solve this. So first thing we should do is find the excluded value and LCD. So I see that 3 minus C and 3 plus C are both different factors. So the LCD is just going to be multiplying the two of them together. And then the excluded value is that we cannot have C equal to 3 or negative 3 because that is going to make the bottom 0, right? So now that we're set with the LCD, we're going to actually multiply the LCD. So think of this LCD being multiplied on every single term. So that's 3 minus C times 3 plus C, and the same thing here, and the same thing on the right hand side, Okay, and then let's go ahead and see what is going to cancel out. The 3 minus c will cancel out here. We have 5 times 3 plus c left, and then 3 plus c cancels out, and it's going to be plus 5 times 3 minus c, and then we get equals to 6 times the whole thing. So 6 times 3 minus c, 3 plus c. All right. And we're going to simplify by distributing the 5 through. So it's going to be 15 minus 5c plus 15, actually that's a plus 5c, minus 5c equals, here we have 9 minus c squared. So it's 6 times 9 minus c squared. That's a difference of square right there. So the 5c's will cancel out. So I actually have 30 is equal to 54 minus 6c squared. And I'm going to move the 54 to the other side. And I'll end up with negative 24 equals negative 6c squared. Dividing by negative 4, I will have, dividing by negative 6 actually, I will have 4 equals c squared. And therefore, taking the square root, I will have c equals plus or minus 2. And because this is a real world situation problem, we can only use positive numbers. So the answer is x equals 2 only. So 2 miles for the current. So final answer, once again, is c is equal to 2 miles for the current. And that is the final answer. All right, we're going to try another one. And let me just clean up here so we could have some space to read the problem and show our work. All right, so problem 2 says a riverboat travels at an average of 14 kilometers per hour. And I just realized that this is a try it problem. So you can go ahead and pause the video and try the problem first before you check the answer. Okay, so hopefully you try the problem. So a riverboat travels at an average of 14 miles per hour in still water. The riverboat travels 110 miles up and down the Ohio River, and in a total of 17.5 hours. So this sounds very much like the last problem that we did. To the nearest tenth of a kilometer per hour, what was the speed of the current of the river? So we have rate times time equals distance again. So the first thing that we are given is that it travels at 14 miles in still water. That means when you're going up the stream, again, it's going to be 14 minus the current speed. And then going down the stream, it's going to be 14 plus the current. And we do know that the distance going up and down is the same, which is 110. And the total time travel is 17.5 hours. Again, to rewrite time in terms of c, it is distance divided by rate, which is 14 minus c for going upstream and 14 plus c going down the stream. So this is how you can set up the problem. And again, because we have the time that is going upstream plus the time going downstream should equal to the total, which is 17.5, and that is how we're going to set up. Or we can just say that it is time total. And so going up the stream, the time is going to be taken all from here. So it is 110 over 14 minus c plus 110 over 14 plus c equals 17.5. So that is the equation. From here, we can find out what is the excluded value and what is the LCD. So LCD, we are considering both of them are different factors. So it's going to be 14 minus c times 14 plus c. And that is the LCD. And the excluded value is that c cannot equal to 14 or negative 14, right? So we're going to multiply the LCD on all terms. So going to have to squeeze it in right here. 14 minus c, 14 plus c. Same thing here. And then I'm just going to pretend that I wrote that over there. The same thing. So 14 minus c will cancel out. So I have 110 times 14 plus c. And then 14 plus c cancels out, plus 110 times 14 minus c equals 17.5 times 14 minus c and 14 plus c. let me go ahead and distribute those two first by the difference of square. 196 minus c squared, that's what I'm going to get. And I have 17.5. Over here, I've got 110 times 14, it's 1540, plus 110c, plus 1540 again, minus 110c. And the 110c's will cancel out. And then combining these two, I will have 3080 equals, distributing here, I have 34, 30, minus 17.5 c squared. I'm going to move the 3430 to the other side. So I will have negative 350 equals negative 17.5 c squared. Dividing negative 17.5 on both sides, I will have positive c squared equals 20. Then taking the square root, I have c is approximately plus or minus 4.5. Again, this is a real world problem, so we can only use the positive answer. So it is approximately 4.5 kilometers per hour. And that is the current speed for this problem. All right, again, I'm going to erase and clean it up so I can do the next problem. So let's go ahead and take a look at the next problem. The next problem is about doing work. So this is a work type of problem. And let's see how we can set it up. Kevin can clean a large aquarium tank in about 7 hours. When Kevin and Laura work together, they can clean the tank in 4 hours. How long would it take Laura to clean the tank if she works by herself? So we have Kevin. Let's go ahead and use K for Kevin. Kevin can clean the tank, so I'm going to actually put the time that it will take for the person and then rate over here. So if it takes Kevin 7 hours to complete the job, then that means in 1 hour, so hourly rate for Kevin is going to be 1 out of 7, right? Because he can get the job done in 7 hours. In 1 hour, he's going to do 1/7 of the job. And then next, we're going to have Lara. And then Lara, we do not know how fast she can clean. So we're just going to assume that she's taking T hours. And then the rate for her would be 1 over T. And Kevin and Lara working together will take 4 hours. So the rate for them together is 1/4 per hour, right? They can get 1/4 of the job done. So like the previous problem, similar, we have the formula, distance equals rate times time. So this one is kind of like time times rate equals, instead of distance, is work done, right? So if you want to consider that. So we want to know in 4 hours how much work can get done, because it takes them both, to do the job in 4 hours, right? So we're just going to calculate in 4 hours what each one of them going to do. So we're going to multiply each one of them by 4. So in 4 hours, okay, in 4 hours, Kevin can do 1/7 each hour. He did 4 hours, right? So that will be 1/7 over times 4. Lara, the hourly rate is 1 over T, and in 4 hours, she can get that much done. And then together, it's 1/4 times 4 hours. So the total work done. Now you're going to notice something interesting here. 1/4 times 4, it's going to work out to be 1. Okay, so this is why when you set up the equation, you will almost always likely see that you set up the equation equals to 1. So let's go ahead and write down the work that is done, right? So work done by Kevin plus work done by Laura is equal to work done by Kevin and Laura, right? So individual and together. So individually, Kevin's work is 1/7 times 4 plus Laura's work is 1T times 4 equals together. Remember, together they get one job done, so it's 1/4 of 4. So we did the work right here. So let's simplify this a little bit. 4 over 7 plus 4 over T is equal to 1. So the LCD in this case is actually 7T. And the excluded value is T cannot equal to 0, right? So with that said, we're going to multiply the 7t, which is the LCD. 7t times 7t. And I'm going to probably finish it over here where there's a little bit of space. So we have the 7 will cancel out. So we have 4t, and the t will cancel out, plus 28 is equal to 7t. I'm going to subtract 4t to both sides, and I will have 28 is equal to 3t divided by 3, and I have t is equal to 28 over 3, or 9 1/3 hours. So that equals to 9 hours, and 1/3 of an hour is 20 minutes. So it will take Lara 9 hours and 20 minutes to complete the job by herself. So that is the final answer. So this is the second type of word problem involved in this lesson. The first one is going up and down the stream or traveling, and this one is work done. So let's go ahead and have you guys try the second problem right here that is based on work done. So you should have go ahead and should have paused the video and try the problem. Let's go ahead and see how this problem is done. A glass blower can produce several sets of simple glasses in about 3 hours. When the glass blower works with an apprentice, the job takes about 2 hours. How long will it take the apprentice to make the same number of sets of glasses when working alone? So in the same way that we set up earlier, let's go ahead and set it up for G for the glass blower, A for the apprentice, and then G and A for both of them. So again, we have time and we have rate. Time times rate equals work, right? So for the, and we can just probably draw, a little chart here to separate our answers. So it'll help us to get organized, right? That looks nice. Okay, so the glass blower can produce the simple glasses in about 3 hours. So time is 3 hours, and that means his hourly rate is 1/3, right? When the glass blower works with an apprentice together, the job takes 2 hours. So it's 2 hours here, and the rate for 2 of them is 1/2. How long would it take the apprentice to make the same number of glasses when working alone? So we do not know how long it's going to take the apprentice, but we're going to make it t hours. And so the hourly rate is 1/t. So since we know the key is that it takes them 2 hours, so we're going to find out in 2 hours what is the work that is going to be done. So it's going to be 1/3 times 2 for the glass blower, and then it's going to be 1t times 2 for the apprentice, and then the two of them together is 1/2 times 2, which you know it's going to give you 1. So the formula that we're going to use again is the work that is done by the glass blower plus the work done by the apprentice equals the work done by both, right? So that is the formula that will be equal. So we know the work done by the glass blower is 1/3 times 2 plus the work done by the apprentice is 1/t times 2 equals the work done both is 1. So you know that it comes from here, 1/2 of 2. And let's go ahead and simplify this. So it is 2/3 plus 2/t equals 1. And so we know that the LCD is equal to 3t. And the excluded value is that t cannot equal to 0, right? Because that would make the bottom 0 here. So let's go ahead and multiply the LCD, 3t, 3t, and 3t. And I'm going to finish it over here. So 3's cancel out, so I have 2t. T's cancel out, plus 6 equals 3t. Subtracting 2t on both sides, and I have 6 equals t, or t equals 6. So that would be hours. So if the apprentice was working alone, it will take him 6 hours to complete the job. And that is the answer. And that is a wrap for today's lesson. So hopefully you've enjoyed applying rational equations to real-world problems. And that is the end of the unit as well for 7 and 9. And you may begin with your homework assignment, and have a nice day. Bye.